Good morning everybody. I am Dr. Chandra Kumar Sahu and I am going to give you some idea regarding truss. This is one example of practical application of truss. This type of structure is known as the truss. Here what happened, various bars are connected together to form a structure. Main aim of this structure is to carry the load and be stable at the loading point. So this type of structure is known as the truss. Here we are going to solve it. It is actually a three-dimensional structure, but we are going to solve only the two-dimensional one. Here various kind of two-dimensional structure are showing here. Here instead of structure we are going to call it as a truss. This truss is formed by joining the bars with the help of pins. So here you can observe that various bars are there. In between two bars there will be pins. That pin will join these bars together, and under the loading condition this will transmit the power. So prior to moving to the solution of the problem, we should know certain assumption. These bars are actually weightless, considered as weightless and connected through a frictionless hinge or pin. Axis of all bar lies in one plane and all forces acting on the truss are applied at the hinge only. So instead of considering the bars, here let it is a bar, it is connected with the help of hinge. We are going to only consider the hinge only and the force applied to the hinge. So let's go to solution or solve the problem. Prior to that, we should know how we can solve the truss problem. So we have two methods. First one is the method of joint. In this type of method, we are going to consider the joint area only. Prior to go for the joint area, we should know that how it is applying. Let it is a pin or hinge. If a force is applied P here, it is known as a compressive. Here we can observe compressive. If the load is away the pin, then this is known as the tensile. After finding out the forces what is applying in the pin or hinge, then we are going to apply the equilibrium equation. It has few steps, very easy one. First step is for finding out the reaction at the end, you have to consider the whole truss as a single one. Okay. And very simplification. At the beginning of the problem, we don't know very rarely no problem will give you that any tensile load is applied here or compressive load is applied here. Let in the example, here is a triangular type of truss is there. Here there are three pins are there, pins, and three link or the bars are there. But when you are going to solve the problem, you have to consider that only tensile load is applied here. For the simplification purpose only. During the solution of the problem, we will know the clearly. Second thing is that, and then you have to apply the equilibrium equation to each joint or hinge. Let's solve a problem, then find out those conditions. So this is one of your exercise problem. Prior to that, we should know that which problem is it? This is 4.27. In assignment 2, problem number 3 also a similar type of thing is there. Here you have to find out various forces on joint 1, 2, 3, 4, 5, 6. So these are the links, and for prior to the coming to the problem, so we should know, we should name each point or joint. Here there will be a joint, definitely name it. Let's start from here. One is A, B, C, D, E. You have to name those point or joint portion, otherwise it is difficult to solve this thing. First beginning, what you have to do, you have to do one major thing, that in the joint some forces will be act. First thing is, we know that P force is applied here, okay, then you have to solve it. So when the P force is applied at the joint of the two bar, so there will be some tension or compression will develop at the joint. Let tensile force will develop at each joint, okay. First do this type of activity. Sorry, my line are not straight. Apply only tensile force at each joint. So don't worry what will happen later. First apply the tensile force. If force will change its direction, so we will get a negative type of answer. So you should not be worry about it. Then we are apply only the tensile force at the joint only. So let select a joint where we should start the problem. So which joint we should select first? So it's better that we should select a joint which has a maximum known amount of forces. So this is the point is E, where we can find out one known force. So let's draw a schematic diagram. This is the point E, and I have already told you that we have already applied a tensile force here and here. This is link 1, this is link 2. So let's draw the free body diagram. This is S1, this is P, the load moving downward, P kilonewton. This is S2. S1 is the force applied on the link 1. S2 is the force transmitted to the link bar 2. Clear? So to know the angle, this angle, we have to apply a simple geometry to find out this angle alpha. This is simple. Tan alpha is equal to P by B, base, this one. See, you will get alpha as 26.56 degree. I am not solving it detailing. This is the 26.56 degree, and this point is E. So prior to that, you have to write everything in detail, just like selecting joint E. Below this diagram, you have to write out free body diagram of joint E. Okay. So let's apply the equilibrium forces equation. Summation of all force along y direction is 0. So what will happen? Minus P minus H2 sine 26.565 is equal to 0. So you are going to find out the P into 2.236. Okay, is equal to 2.-2.236. Here our assumed direction is tensile, but result is coming in the negative direction. Means you have to go for a, you have to write here that compressive force is developed, only compressive force. But we remember that we are not going to change this direction for the simplification, but we are going to write the answer as a minus 2.236 into P. Minus symbol should be there. Okay, this is the point T 1, 2, and all as the tensile force. Then you have to apply the another equation. Summation of all force along the y direction will be 0. Sorry, after y, x direction is 0, minus s1 minus s2 cos 26.5 is equal to 0. S1 is equal to minus 2.001 P. This is also minus, so we have to write it down. Compressive. So after that you have to find out another one part is completed. So let's go for another point. Here if you are going to find out other part, here we know that two parts is remaining, you can find out simultaneously, point C or point D. If you are going to look at the point D, so it is only 3 force is there, but at the point C 1, 2, 3, 4, 4. So selecting pin D, because less force are involved and one known force is there, that is 2, S2. Okay, you have already calculated S1 and S2. It is very easy. Then the similar thing at the point D, you have to draw the force system. This is S2. Why? Everything is in tensile from the point D. Point means this is the pin D. Okay. This is S3. S4. This is 4. This is 5. This is 6. Just apply the same thing. Summation of Fy is equal to 0 and summation of Fx is equal to 0. You are going to find out S3 value and S4 value. After that you have to go for selection of another point, that is known as the point C, this one. Pin or point C. So prior to moving to this thing, I would like to say you to understand these problems. These are the simple structure, and where we are applying few amount of load, and we are going to find out the forces at various points. So first thing is that you have to select each and every pin, and you have to consider each pin and at the tensile load condition. If your answer is negative, that means that load is compression. Okay, you you don't need to worry. And remember that one more important part is that there is a relationship between these joints and the bar or link. Okay, for a structure to be statistically determinate, the equation should be 2j is equal to m plus 3. J is equal to number of joints or pin, m is the number of bar or link plus 3. Let this is a structure is there, the number of joint is equal to 1, 2, 3, 4, 5. Number of bar is equal to 1, 2, 3, 4, 5, 6. Okay, is it right? 1, 2, 3, 4, 5, 6. Okay, 6, 3, 9 and 10. Okay, you should not be worried because here to here also a link. So this is a 7. Okay, so this is also a link because this is connected and this is a part of the structure. So we can find out that this relation is satisfying. If relation does not satisfy, then the structure may not be stable one or indeterminate one. So we no need to study it now. So if you have any doubt, just comment me.